Hello everyone, and welcome to another episode of What's New in Autodesk Nastran in CAD. I'm Mitch Muncy, Product Manager for the Nastran products. There have been a number of improvements made to Autodesk Nastran in CAD in the most recent update. The first group of improvements we will look at fall under Ease of Use. We have made it easier to determine where you've applied loads and boundary conditions to your models. For example, when you now select a constraint from the model tree, it will highlight on your part to help you quickly identify its location. You can then see where the load value is or what degrees of freedom are being constrained. We have also modified the bearing load so that the arrows point normal to a surface. As always, this is a great way to simplify your model as you no longer have to create a cylindrical part to apply this load, as it can just be represented by this vector value. The process for creating and editing connectors has also been improved. A previous and next button have been added to allow you to easily move between editing existing connectors as well as creating new rigid and bolt connections. These connectors could then be grouped, allowing for easier selection and modification. Additional updates have been made to the ribbon to both more clearly represent what the buttons will do as well as simplify the design process. As you can see, the mid-surfaces and fine-thin bodies option have now been placed underneath the offset surfaces option in the Prepare panel. Another exciting improvement is that you can now connect your results from Autodesk CFD to your Nastran in CAD designs. This means that thermal or pressure loads from your temperature and fluid flow profiles can now be easily included in your mechanical stress analyses as well. Both temperature and pressure values can be carried over to Autodesk Nastran in CAD. Since the meshes on your parts will be different, a mapping process is used to take the results from the CFD mesh and map them to the corresponding mesh in Autodesk Nastran in CAD. This can map external surface pressures and the entire temperature profile for the solid model, then being included in your structural analysis. Here we have a model of a valve that we set up in Autodesk CFD. This model uses symmetry. We ran the analysis to study the temperature through the valve. We can then bring these calculated temperatures into Autodesk Nastran in CAD. To configure our thermal stress analysis, we will start by suppressing a few components that aren't needed for the analysis, such as the fluid. Next, we'll create the temperature load using the CFD result. You can select the specific time step of interest and the result that you want to map. After the analysis is complete, you can see the effect of temperatures in a thermal stress analysis. The last set of enhancements we'll be looking at are related to the Autodesk Nastran solver. Plane strain elements allow you to simplify your model by representing thick solid geometry with shell elements. Using the shell idealization on Autodesk Nastran in CAD, you can now select the plane strain formulation under the advanced options. The response spectrum analysis type has been added to the list of linear dynamic analyses available. You can now look at time history events such as earthquakes or wind loads and see how they will affect large structures based on their natural frequencies. This is applicable to a number of industries such as energy, aerospace, shipbuilding, offshore, construction, and many more. Here we have a simple building model with beams representing the frame and shells representing the windows and floors. Under the analysis type, after selecting shock response spectrum, you can set the various Nastran options for your analysis, such as lower frequency bound, weight mass scaling factor, and summation options. Modal setup allows you to choose your number of modes and other options. Damping allows you to set your damping. And dynamic setup allows you to define the response spectrum or spectra. Multiple spectra can be used for different damping values. These values can be displayed on the graph. There is a new constraint option specifically for response spectrum. This defines the excitation point. Using the rigid body connector in Autodesk Nastran in CAD, we can connect our excitation point to the foundation of our structure. Using the mass idealization, we can create our foundation mass. Compared to a full transient or frequency response problem, the response spectrum analysis solves very quickly, and we don't need to sort through hundreds of output sets just to find the maximum displacements or stresses. The final enhancement we're going to look at today is the performance boost to analysis speed across the board. With the improvements made in Autodesk Nastran 2018, we are seeing linear analyses run 3 times faster on average, modal and buckling 2 times faster, and thermal analyses running between 2 and 3 times faster for parts and assemblies. Thank you for continuing to make Autodesk Nastran in CAD a great product. We look forward to your feedback, and be sure to check out the Idea Station and submit your ideas for a future release of Autodesk Nastran in CAD.